seeing familiar faces. So thank you for joining. It is being recorded and uploaded later on to our YouTube channel, so you can watch it in your free time if you have nothing else to do. So this is another session. This is the 29th meetup of the San Diego C++ meetup. Is anyone here new to the meeting, to this series of meetings? Hey, Jeffrey, nice to see you.
Good to see
Hello.
you.
Yeah, you can see Tom Ajinkya. I don't know if I pronounced the name correctly.
Hey, hi.
Hey, yo, good. Very happy to see you all. I am trying to make it fun and uh, kind of a learning experience and something that we can all learn. I spend a few hours of my time during weekends here and there to get the session up and running. I am welcoming anyone that would like to present 15 minutes, 10 minutes, 1 hour talk, no matter what, would be always I was always appreciate that and always welcome. So the way I operate, usually I take a look at what happened in the C++, I would say, world in this month, and trying to collect all kinds of interesting things. Some of that related to things that I'm seeing either online or while walking. Some idea that I wanted to share with you would be uh, an item on the agenda. We have a lot of things today. I'm planning to have it like 1.5 hours, uh, and I'm already sharing, so you should be able to see my screen. And yeah, let's start. Obviously, if you have any questions, please feel free to kind of stop me and chime in. Let me go into presenter mode. Okay, so the presenter mode. Okay, let me swap it. Okay, you should be able to see the non-presenter mode. I think you do. I think you should be able to see that. Okay, do you see it flipping? This is the agenda right now.
Yes.
So if you're a new member, what I mentioned right like a couple of minutes ago, we need you. We definitely appreciate any talk that you would contribute to the meetup. I am trying to bring in all kinds of big names. I contacted uh, very big names, and this is in the pipeline. So big names in the industry. So hopefully that would happen. We already, by the way, had few sessions in the past few months. I was in Israel for a few weeks, and I got back uh, kind of August 9, so I was kind of behind of getting this session up and running, but I managed to kind of spend few hours in the weekends and get that happening. So yeah, by all means, if you have anything that you would like to contribute, let me know. Now, I don't have visibility to the chat. Let me see if I can take a look. Okay, so I should be able to see that, but just chime in if because I'm not always looking at the chat. Okay, so agenda for today, there is some C++ jobs at Qualcomm. Hiring managers asked me to post some, so that would be one slide that I'll actually a couple of slides that I'll post. My favorite, not really favorite, but it's like a fun part of the meetup is the C++ quiz from the website C++ quiz that's kind of randomly cherry picking C++ questions. Some of them are easy, some of them are not, but everything that we see would be kind of a learning experience. We have Stack Overflow question of the month that I thought it would be interesting to see there is some uh, knowledge that I would like to share with you looking at this Stack Overflow. There is a book recommendation. Actually, there are two books from the same author. Uh, just one is a first edition, CPAPAS 17, and the second one is CPAPAS 20 that I really like, both of them. And then there is this recap of past books that I'm planning to have as kind of chunks maybe every meetup. I'll kind of have a refresher of what I had before, because people are always seeking for books recommendations. So I'll have that. Actually, I'm gonna have it at the end if we have time, because I want to stop at 6:30. Um, and then I would have a some few slides about order of evaluation, some examples of what happened to order of evaluation in C++ 17. What does it mean? What is resolved, what is still not resolved, and you need to make sure that you understand. So we would have a few slides. I think this is very interesting part that I personally had a lot of learning experience from. And then my favorite website, Wallet Folks, that if you know my previous sessions, if you've attended that, I'm a big fan of Wallet Folks work. Um, I think somewhere, is it Germany? I can't remember now, or maybe Switzerland. Sorry, I can't remember. But this person has a very nice, very recommended a booklet of ranges, C++, ranges v3 that C++ 20 is based off, and of course 23 improved. Highly recommended, great artwork and very informative, and it has a lot of stuff in the website. I'll show three slides if time permits. Okay, this is, as usual, I mentioned Qualcomm WRT software that I'm part of this group. Um, so WRT software, thank you for sponsoring the meetup fees. We have a Dropbox. Hopefully everyone can reach the Dropbox. Everything here would be uploaded. There is a Slack channel that I barely joining. I'm actually barely kind of opening my Slack. Everything now moved to Discord these days. Should we create Discord space? I don't know. If people feel strongly about it, I can definitely do that. What do you think? Let me see if there is any thoughts about it. So think about it. If you think that this is worth doing, I can definitely create a Discord space. Okay. We have a YouTube channel, so you can subscribe if you're looking for past sessions. We have a Twitter account that I'm managing. My Twitter account would be Kobe_CA. Kobe is my nickname. Official name is actually different. So let's jump into the C++ jobs at Qualcomm. So first of all, they asked me to, if you apply or if you know someone that would apply, have my name so they can track the origin of the recommendation. Have my name, which is kobe.cohenarazi@gmail.com. There is like, how did you hear about us? Qualcomm employee, and you can have my email address. Then the job posting would be the one that you can see here. There are a few in San Diego, a few in Boulder. There is one in Austin and one is Canada. So Canada has a lot of AI stuff and ML. So there is one over there in San Diego. There are a few. Some of them are machine learning. Actually, this is from the research department, specifically from research department, where they do a lot of XR and ML. So there's a lot of nice things happening in this department. So if you're seeking for looking at this specific domain, so it's there. And Boulder has some couple of them also, accelerator uh, and firmware for machine learning. So if you need anything, you didn't have a chance to look at the slide, and you need help, just contact me either via my email, LinkedIn. Like if you Google my name, it's very easy to, I don't know, steal my identity. I think it's very easy. Like my name is like in many locations, unfortunately. So just let me know if you need any help. Okay, so let's start with the fun part. The fun part would be the first. Oh, what I'm going to do. Okay, I'm not sharing yet, so I'm gonna share it now. Okay, so take a couple minutes, read through that question. Okay, let me just do this. Is it too small or is it okay?
Yeah, I
Yeah,
think
it's
that's
okay.
okay.
Okay. So I'll give you 30 seconds and then I'll start talking. Okay, let me just start breaking it into small pieces. We have a global X here, which is initialized to 0. Okay, so it would be initialized to 0 even before main. So that's one thing. The second thing is that we have this foo function with static. Again, it would be initialized when we enter the function. Okay. What else? We have a class A and a class B. Let's start with B because B is kind of simple. It has a constructor and destructor, user defined constructor, user defined destructor, and it has an instance of A, like that we created instance of A when instance of B is created, and it's a data member. It's in public. Doesn't really matter right now. So it prints B like lowercase and uppercase. Okay, so that's one thing. Let's take a look at A. So A would have a constructor, a user defined, and user defined destructor. User defined destructor would have capital. The user defined constructor would have a lowercase, and then if X and there is a post increment. So first, like if this is running, the first one would be if X equals 0, which would be true initially, and then it would be 1. So there is a std exception that been thrown. And then there is a main and there is a try catch. So foo is being invoked with who is this function. Again, this is the difficulty 3 out of 3. So there is an exception. I by the way, I usually catch it by const reference, but that's not a big deal here. It's not. And then if there is an exception that being caught, C, like lowercase c, would be invoked, and foo would be invoked again. Okay, so let's try to kind of see what's happening. Main is invoked, foo is invoked, static B. So remember what happened. Oh, by the way,
I
kind
believe
of
it should
going back
crash,
to
right?
A. Sorry,
I believe it's going to crash. Or it's going to exit. Are
gonna
you
gonna
asking a question or are you going
exit.
to say?
Oh,
Yeah.
no. There are a few options here. Either it's
I see.
guaranteed to output something, or it's compilation error, unspecified implementation defined, or it's undefined behavior.
Oh,
The one thing before we start running the whole logic is that kind of a hint, just to remember that it's pretty important. An object is considered to be fully constructed if the constructor is finishing without throwing. In other words, if I'm creating an instance of a specific type and the the constructor is throwing, or any, if I have inheritance, which we don't have here, we have aggregation, but if something is throwing member, like even data member is throwing, the constructor is not finishing, like we don't hit this curly braces. then the instance is not created. There was no instance. The destructor would not be invoked because there is no instance to destroy because we didn't finish the instance. This is what I like in this whole question 15, is this specific uh, kind of knowledge that people need to understand, especially if they're throwing from constructors. And there's all kinds of subtleties that not shown or exercised here, but just keep this in mind. Okay, so I'm invoking foo, which creates static b. So I'm actually start initializing b. So let's go to b. So b is sorry, b is being initialized. And one of the things that happens before we actually going into the curly braces, the opening curly braces, all the base class, we don't have base class, but all the members would be initialized. What do we have here? Which member we have here? It's A, right? So before we actually hitting these curly braces, we need to initialize A. This is why I'm always saying, and people that know me from Qualcomm, from the weekly session, that I'm advocating to use the initializer list, the constructor, sorry, initializer list, because it is the best way to initialize your data members. Once you entering the curly braces, the data members are somehow initialized. Depends on the data member, but either they don't have, like, they have arbitrary values. Let's say they are primitives, or they have a default constructor, so default constructor would be invoked. So just remember that before you enter the curly braces, the members are being initialized. So okay, so A is being initialized. So let's go to A. So stood out would be A. So first of all, do you agree that we would have A?
Yeah.
Yes.
Yeah. Okay. Okay. First of all, we don't know if it's going to be a compilation. Is there any compilation error here? Let's kind of clear this. Do you think there is
Did
going
you
to
say
be a
computation or compilation?
compilation error? Do you
Oh,
see the, do you think there's going to be a compilation error
I don't
like
think there was
this?
any compilation error.
Yeah, it doesn't seem like it's going to be a compiler. Okay, there's nothing wrong as far as I can see, unless someone think otherwise. There's nothing wrong in the syntax. Okay, so it's either implementation defined or undefined. Let's try to just go with the flow and see if it works. So let's say A is being printed. Now, is this going to be happening? Is this expression or this branch going to execute?
I think so.
You think so? Why? Why?
Because we are going to check the condition before we increment it.
Yeah, so X is 0. So we're throwing. Okay, so we're throwing, we're winding up the stack. So if you look, if you were hitting a breakpoint, if you're doing a breakpoint here, you'll see the stack, and now we throw an exception, we start winding around the stack. B was the one that that started the whole, like the main of obviously foo. So we're going back. P is not constructed, right? Because we're throwing even before we actually hitting the curly braces. Do you see my cursor, right? I'm actually pointing, hopefully.
Yeah.
Then we go back, and that was coming from foo. No handling. What happened? It's propagated up, propagated here. We are in a try catch. We're catching stood exception, and it's printing C. Would C be printed?
Yes.
Yes.
Okay.
Yeah.
And we're running foo again. So let's run foo again. Now, are we going to remember what I said? The static BB would be initialized once when we first hitting this function, but we already tried to initialize it. I kind of constructed, not initial, constructed, but we kind of failed. Is it going to be reconstructed or not?
It should.
I think it'll try to do that.
Yeah.
It would remember, there is still no B. There is no spoon and there is no B. So we should go and start the whole thing again. So we're going here. We constructing A. So A is here. Should be what happened here. So we're constructing A.
Uh,
So
now
we
we
should
should
have
now we
we
have
should
to
have
already
A.
implement it. We don't throw the exception, right?
We don't have the exception. All good. A is now constructed. Now B is done initializing the members. Now we start going into the body. So we have B.
Right.
We are done constructing B.
Mm-hmm.
We are done here. Function returns. Okay. And main returns. What happened when main returns?
The destruction of the sequence will happen.
Destruction of sequence. Which one? What do we have here as global, or not really global, but it behaves like a global?
Yeah, the static
The
probably
static
should.
B. The static B. So B start destruction, right? So we have A, C, A, B. That was the construction part. Now we start destruction. Okay. So what happened? So what happened in destruction? What do you think happens? Destruction is the reversed order of construction. So what is happening first?
So we have to print B.
Capital.
Actually, we have
capital,
to delete A. Basically, it's going to delete A or destruct A first.
Destruct A. Are we done?
No, I think it should print
prints B.
capital B. It should destruct first B.
Yeah.
Yeah. So we destruct first B.
Yeah.
And then we destruct A.
Right.
And we are done. Okay. Now we need just to make sure that we are. By the way, I don't know what.
Actually, there should be a compilation error though. Here, main is defined as it's going to return int.
Yeah.
And there should be a return 0 or something.
No, that's fine. That's fine.
Okay?
It's a good. Actually, it's a good point that you're bringing. It is implicitly will return 0.
Okay. Only for the main function, right?
Yeah, the main function. Now, one thing that I wanted to mention before I click this answer, just to see that we are correct. I don't know what would be destruct. Like X is not really destruct, but if it was a non-trivial object, I don't know what it would be happen. What would happen in terms of order? Is it this one or this one? I don't know. I don't know if it's specified. We don't care right now because there is nothing here. There is no side effect of X.
Does it matter on that ordering?
On this specific question, we don't care. It sometimes would care if I make this question a bit more harder, and I ask what is going to be destruct first. I don't know if it's specified. If someone knows if it's specified or not, I think it's unspecified. But if you think otherwise,
I think it should be the last one to destroy, right?
I'm not sure it's specified.
Okay.
Okay. So this is correct, and there is. So first of all, it is compiling, and it's not undefined. It's not unspecified. Everything is here. It's fine. But the important part, just take away from this exercise, is construction order, destruction order, static, first time, and do we have a construction happening if I'm throwing within the constructor? And I think there is here a constructor is aborted. Basically, the instance was never created.
Mm-hmm.
Okay, so this is a very kind of a hard question. Let's go to
one quick question. Is there something like the destructor can be also aborted through an exception?
Good question. You can, not recommend it, you can throw from the destructor. If I'm not mistaken, it would eventually calls to the abort if you're throwing from the destructor. It might, and you are, and I think I can remember the rules. If someone remember, can chime in. It's either when you are, okay, if the destructor is throwing and you are inside a unwinding stack of of exception, then abort would be invoked.
Okay.
And if someone thinks remember the rules, otherwise let me know. This is why they say don't throw from a destructor, because when we have when we're throwing and there is destruction started on all kinds of instances, and one of them would throw, you have a nested you have an exception within an exception that is in flight, and abort would be invoked. And I think there is this stewed can remember unhandled exception, or can remember the
Abort, that means the program crash, or I don't know what to mean.
yeah,
Abort
abort is
crash.
would be crashing. This is but I can remember. Okay, what is the name of the stewed unhandled exception, uncaught exception, or something along those lines? Oh, stewed terminate. Yeah, so stewed terminate would be invoked, which is abort by default.
Okay.
The default terminate handler, so you can install a different handler, would be stewed abort. Okay, let's go back here. This is easy. So let's take a look at this function. What happens here? Okay, again, there is these options.
Oh, it's
Okay.
a division by 0.
So
Division
it's
by 0, which
exception,
is
it crashes.
it's undefined behavior.
Yeah.
Okay. And if the compiler catch that, I think there is a trend. I'm reading, the more I read about that, there is a trend of compilers exploiting undefined behavior more and more. Oh, it's an when the compiler logic says, okay, this is an undefined behavior, because in this case, it's clearly something that the compiler can even understand during compile time. All kinds of stuff can happen. I don't know what would happen if I put it in Godbolt. And I put.
So you mean the compiler would catch this one?
This is an undefined behavior. Let's see what happens. So let's take GCC. Yeah, let's not do IOStream. Let's there is a C out. Okay, this is why there is an IOStream. Okay, we'll deal with the. Okay, so what is UD2? Generate invalid opcode exception. Okay, so so that's what happened. So program returns 132, but it's an undefined behavior. So I don't know what, let's say, Clang would do. There's like all kinds of stuff, but we don't really need to go through. Just if you want to see what the other, where is my Clang? Here it's my Clang. Okay. Take a look at trunk. And it just returns something else. So what is the function with what main returns all kinds of stuff. Interesting. Okay. Let's go to the next one. This is kind of 2 out of 3. CPAPA 17. What is the output of this program?
This one should
We have
be
a character 3, a character 2, and we just
one,
It's
right?
a 1.
Assuming that
why
they are in
why
sequence.
why 1?
Because the ASCII value, it will put INTI. The ASCII value difference between 3 and 2 is always 1. Because
We don't even need to know what the ASCII number of 3
yes,
in integer. It's just consecutive. It's 1. We're all good. Okay. By the way, it is character, but it is basically an integer promoted to integer. It's basically the ASCII value would be an integer. Okay, it's kind of, it's 2, but I think it's kind of very nice and easy. Just a reminder that these ASCII are just basically in integers. Okay, The next one would be another C++ 17. By the way, most of them are C++ 17. I don't know if they have 20 added to the C++. If you want to take a look, I think there is a link somewhere to the GitLab. Anyway, you can figure it out. So we have, take a look.
So C2 is equal to C1. So copy constructor or something like that. No. Oh, C2 is equal to C1.
I believe it must be 1 and 2.
One and two.
Say it again.
1, 2.
1, 2.
Yeah.
Let's see.
Actually, it should be
1, 3, 1,
1,
3.
1, 2, and
The
3.
assignment,
Okay, whoever
right?
said
So it
1,
should
2,
be
and
1,
I
3.
just blindly just hit 1, 2 was right. But this person needs also to explain why.
Yeah, I can explain. Well, I think the 1 is self-explanatory. You're constructing C1, so it'll print 1. And then because C2 is not initialized, you're not actually going to use the assignment operator, assignment constructor. You're going to call the copy constructor. It's one of those first things I think that I think it's the book is quite outdated now, I think, but it still has some useful tidbits. It's I think Scott Myers, Effective C++. He highlights this in one of the first few chapters.
Yeah, yeah. This
So
is
that,
not copy.
so
This is copy as what we call copy assignment. It's assignment of already existing instance with another instance. But during
shouldn't that be,
constructions, sorry,
there's one question on that. C2, shouldn't that be within the brackets, like C2 brackets and C1?
What is the argument for that C2, right? For the copy constructor to execute?
or C1
Yeah,
is
so
the
C1 you can do it, right?
argument is the argument to the other. The other is the parameter, and when we're passing an argument, which is C1.
It's just
And
initializing
by the way,
part.
yeah, if we already kind of on it, I think this is an important, like, I know C++, like the whole initialization is kind of a fiasco. I'm sorry, I'm just the messenger here. I'm not part of it. But yeah, what I wanted to say is there are multiple ways to do it.
Yeah.
C1 or C4. I think even this would work. You know what? I can remember. Let me see if that would work.
That is if you start with that is the initializer list, right? No, sorry.
Sorry, say it again.
When you have the curly bracket.
Yeah, but this is basically like the uniform initialization, and I don't even want to go there. If what happened if I have another constructor with initialize the list as a that's another fiasco. But basically, what happens here? You can see here, 1 is here, and this is 2, and 2, and so on and so forth. All of them are the same. Just don't get confused. By the way, don't do this. What is this?
Just a constructing object. Let me show
So
one.
No, don't look at
So
this.
this is the default constructor, I think.
What is that? You're using brackets after that?
Yeah, what is this? What is this C5?
I think default construction, so it should be
Default
just one.
constructor we are called, right?
Okay.
So in line number 11, right? So in line number 11, if you have already, if you replace C2 with C1, then assignment operator like would get called, right? Because C1 is already initialized by that logic, and if C1 is equal, sorry. What I was trying to say is, if a variable is already initialized and you try to do assignment with another object, then 7, line number 7 would get executed. Is that correct?
Yeah. If we have C1, C2
already defined,
and I do C1 equals C2, that's line 7.
Yeah.
Okay, but let's ignore this. What is this?
That is just the construction.
Yeah,
Default
C5
construction.
is the default
It's not a
It's-
it's not a construction.
I mean,
Who said this? Who said this ugly phrase right now?
this is Ravi. And that is like a default construction,
It's an
right?
ugly phrase, but yeah, it is the right thing. You see this?
empty parenthesis.
Yeah. The compiler thinks it's a function prototype, so
It's a function prototype. What smells like a function and looks like a function would be considered as a function. This is like, what happened? So this is a function
Okay.
that
That's interesting. Yeah.
returns
function
C because C is a type. It's a function
Yeah.
declaration.
Returning
It's a
C,
function
yeah.
prototype.
All right.
The
Returning
name
C,
of the
yeah.
function is C5, and it has no
Yeah.
parameter, no
Right.
params.
That's a catch.
But this is fine. You don't really need to do that. But this is fine, which is the same as as this. But the curly braces fix that.
Okay.
Okay. By the way, every programmer, or almost every programmer, maybe there's some very very talented one which didn't have that, but every programmer would have at least one in his or her career. This and today, by the way, things are much. This warning from Clang, I don't know what GCC would do.
In this particular example, the line number 17, if the constructor has one argument also, then there will be no any confusion, right? When you create the object with one argument in number 17.
Okay, let's try it. If I do int here and I put 42.
Yeah.
Now the thing is, it's
Yeah, compiler.
now the thing is, it doesn't look like a function because 42 is not a type. It's
Right.
it's a literal. It's that, so it doesn't look like a function anymore.
Right.
But this one is as if you were writing void, and now it looks like a function. The fact that it's C5, but I could, if I put here the word func,
Yeah.
right? It looks like a function.
Right.
What I'm saying is that there, I, in my opinion, at least everyone would have at least one error, and compilers are really good at it. I remember one of my team members. I don't know if he's here. I'm not gonna name. Let me see. He's not here. But anyway, there was, I remember that was 16 years ago. It was in Qualcomm, one of the first project that I was working. And the compiler was like, GCC 4, GCC 3 or whatever. It was very, very cryptic message. You can't really understand what's happening here. So the compiler got really, really better in this. Okay, the last one, 145, C++ 17. C++ 17 is the fact that it's 17 is important in this question.
Return E.
Okay, so what do we have here? We have a struct E, we have a constructor, we have a copy, we have a destructor. We have F that returns E, just constructing E and returning it by value.
I think this
Right?
will return 2.
1.
1. I'm blindly gonna have 1. Let's see. Whoever said 1 would need to explain if it's correct or not.
It's
Not
right.
correct. Okay, so let's
Should be 2.
try to see. Sorry?
Because it's going to return a copy of the object that is being created.
It's a copy of the object. Okay.
Yeah.
Anyone knows what are the new rules in 17 about copy?
Isn't copy elision a thing?
Copy elision, yeah. There is a copy elision here. What does it mean, copy elision? Can you explain?
Basically, if the compiler can get rid of a copy, it will.
It will, yeah. And the compiler can get rid of this copy. So we have a construction and destruction. So we have 1 free. So let's just, and there is all the clauses from the from the standard. But let's see what happened. F is being invoked, then E is being created. So this is one. This is the one part. Then we can create a copy, and then everything is destruct, right? Because we don't do anything. And let's take a look. Just if you're curious, let's take a look what happened. So this is C++ 17 because I
Can
already
we
have.
try with the C++
So
earlier version 11?
Let's take a look at 11. Now 11, they might do elision as a courtesy, right? But I don't know if 98, like lots of, especially with this very simple, like what 17 did was a mandatory copy elision, but compilers were very, okay, let's take a look at GCC, whatever, I don't know, the first one. No new line, okay, I don't know what does it mean. But it doesn't say anything. What the heck? Okay, let's see. Let's try 5. 1, 3. It's not gonna work. It's not gonna work because they are very smart already from the very early days. You know what? Let me do this. Let me see if it makes a difference. No, it doesn't. So I don't really know how to convince you that compilers used to be dumb. Maybe they're already smart from 2.95. Maybe Clang would be different. Let's take a look. Clang. Where is my Clang? Here is my Clang. 3. IOStream not found. Okay, this is a bug report to Compiler Explorer. 1, 3. Okay, I give up. Everything is optimized from day one. So, by the way, I think there is a switch. If someone can quickly Google, there is a switch of no copy elision. Can someone, I Google, C++, let's say GCC, no copy elision. Is there a way to disable? I remember there was a way. Oh, here. Okay, let's see. Ta-da! Even with O3, let's see. Yeah, we did it. So seriously now, the compilers have been very, very smart, and they can eliminate code as much as possible. Even, by the way, there is a std out here, so there is like something that maybe someone wanted to kind of do system rm-rf and just to do something in the copy constructor, but it's elided. And if you really want to remove this behavior, there is a switch. Okay.
But where do we see that the compiler has disabled the elision?
So you can see that it's 1, 2, 3, 3. We have a 2. We actually have 2 3s. I don't know where the 2 3s are.
Well,
We can definitely think about because there is a copy and there is a destruction of 2 things.
Right. Okay.
Because there is a 1 of the main one, 2 of a copy, and now we have 2 instances in memory. Both of them would be destructed. This is why we have 2 3s.
Yeah.
So
if you want
2 copies, one is when you return a value, it will at a time. Is that the one that we're talking about? 2 copies. Where are the 2 copies? Can you?
So there is a construction here.
Yeah.
Construction here because this one would be. Now we have 2. This one and this one.
Got it.
Both of them would be
Had it been the reference, then it would not.
No, reference is different thing. Right? Reference is like if I return a reference of a temporary, that's a different thing. But I see what you're asking about. Reference is reference. There is no construction. Reference.
What would happen if there is like a move type of thing? There's like
move is we don't have move here because we define we specifically like we have a user defined constructor, copy constructor. Sorry. So there is no move here. So So this is a different, like this is a different exercise that that we need to take a look, but it's gonna be different. So if you want your code to walk slower, use this switch, compiler switch. It's a very handy if you want to prove something during in benchmarks and you want to cheat. Just use this. I'm kidding. Don't cheat. Okay. Let's go to the next one. Let me just reshare. And again, this is something that I find very entertaining because you can learn a lot from this C++ quiz. Okay, let me reshare this one. And for some reason, I cannot see any share. Okay. Okay, now I can see it. Okay, let's swap it. Okay, the Stack Overflow of the month. Okay, okay, so to go back to here. So let me reshare it. 1 second. Stack Overflow of the month. Okay, so the question was, is there a way to avoid implicit conversion to void pointer? Long story short, a person had a function that accepts void pointer and like an API. And the idea behind this API, first of all, it's a great API, accept everything. I'm kidding. Don't use, if you have an option, don't use void pointer. But the idea was that only that API would only accept void pointer. And accidentally, this person was passing a different pointer, and void pointer would take any pointer, right? So there is a function that has a parameter of void pointer, and if I pass an address of some integer, right? I have int I equals 0 or 7, and I pass the address of I. It's being implicitly converted to void pointer. The function would be accepted, and he said, can I make sure that I disable everything but void pointer? And that actually brought me into a very nice kind of not such a known feature of C++ 11 and above. Okay, so let me go back to the slides because I have a story. Okay. Okay, so some background. So C++ 11 added this equal default and equal delete, right? So without going into greater details about default and delete, but basically, let's say I want to have, I have a class or a struct, and I have a constructor that has parameter. So it's not the default empty construct. I don't have the default empty constructor. So if the moment I define any constructor in a class or a struct, I'm losing the empty constructor. The compiler would not generate this constructor for me. If I want to bring it in, C++ 11 gave me this equal default option, which is really, really handy. For example, in this specific class foo, I have a foo of the text int, and I want to bring back the default or the empty constructor. So I do foo empty, like parentheses, open, close, equal default. The compiler would generate this for me, and I can actually call foo with an empty, with no call the constructor with no argument passed. So this is a very nice feature. But in addition, there was also another feature where actually I can remove functions from a class. So let's say I don't want to allow copies. Like I don't want that foo would be a class type that has a copy semantic. I want to remove that. So I can have this, and this kind of coming in pairs, the foo, copy constructor, and the assignment operator that we mentioned before. I can just write them equal delete. Before C++ 11, there was all kinds of tricks. There was this boost uncopyable that you need to inherit, but now we don't need to do all these funky tricks using boost and all. It's part of the language syntax, which is great. But the thing that is not really known to many people is that I can actually have equal delete of any function that I want, and it's going to be removed as a viable candidate in my. So you know, when you call a function, the compiler goes and there is like a huge big rules of how the compiler creates this candidate list and how the compiler picks the best candidate, and if the best candidate is not there, either there is no best candidate or maybe there is ambiguity, all this stuff. Go CPP reference or the standards. Very fun read before bedtime. Kidding, of course. It's a very tedious thing. So basically, I can go and change the way the compiler picks function. So I have a Godbolt, like a compiler explorer example here. So I'm gonna open it. Give me a
question
sec.
though. Isn't this a C++ feature? But the question could be related to C also, right?
There is no equal delete in C.
Yeah.
Unfortunately, or fortunately, it depends. Probably C folks, they don't really want all this stuff that C++, but you need to go to the San Diego C meetup, which I don't know if such exists. I don't know. I have no idea if such exists. We barely had C++ 2.5 years ago. Okay, so here's an example. So the example is pretty. Ignore this because this is kind of the explanation. If you want to go back to the slides, I have a function that takes double, and it doesn't really matter what the function is doing. So I have an auto D 2.0, which is a double, and function that I pass D works. I can also have function F, sorry, auto F, and I pass the function, I can pass it F. And it's fine because double can hold float, all good, and we are fine. But let's say that I want I'm making up a scenario, just extrapolate it to any use case that you might have in your code base. I don't want anyone to pass floats to my function. I want everything to be double. And if someone pass float, I want that to be flagged as a compiler error. So what I'm doing, and you can, sorry?
Make it explicit.
So what I can do, like one option, maybe there are others, but what I can do is I create this function. So now it's a viable candidate. Like the compiler would come and say, okay, I have function F. Let me see what I have. I have double. Good, I can do it. I have float. Actually, float is better. Let me pick that. So I'm picking that. Oh, it's deleted. I'm stopping here. So I'm using a deleted function, and the compiler would error. So there is a compilation error. Okay. So the idea of whatever the Stack Overflow proposes really is really this. This is the idea behind what the answer, like all the answers that in
So
this.
what happens if we use the explicit to define the function to just accept only double?
If we have a this is a function that accept double.
Yeah, I'm saying explicit, the keyword explicit, if you use that.
The keyword explicit is something that is used for constructors. There is no something like this. Oh, sorry. There is no something like this or something like this. There is no something like this.
Hey, Kobe, is it possible to use requires with, I see that you compile with C++ 20?
Oh, yes. There is a way to do that, but I'm not showing it here. And I don't remember if but yeah, there is a way to constrain it in a different way. I could actually have more ways. I could actually have a static assert if I don't have 20. Gil, is this you?
Yes.
Hey Gil, how you doing?
Good.
So
Pretty good.
I could actually have a static assert that actually I can't have static assert here. It's only if it was a template. But yeah, because if it's a double. But requires if it was a template would be an option.
Yeah.
But it's not a template, so I can't really use it here. If you have a different method, it's C++ 17. Please share it with the group. I don't know how, maybe with.
What about the is same v or something like that?
Yeah, but there is no type here. What you're actually saying here
Got it.
is this, and now I can constrain it with requires.
Yeah.
And with static assert, with is same. So I can do static assert here. Right? That would be with the right
Yes.
static assert, I think, is like this, and is same b t double. You can have here something. So static assert failed because of this, and again there is a require, and maybe we would have something next month about concepts, like very light, no, not crazy stuff, just to get a feel about C++ 20 and how template programming made easier with concept. Okay, so let's go back to our slide deck. Where is it? It is. So Stack Overflow, what was you already have the gist of it. So what the Stack Overflow said was the following, and let me just go through that. So this is the API function. This is the API function. Ignore this for a second. And what I'm doing, what the guy or girl is doing, what this person is doing is that it has a function template function that accept everything, and it's deleted. Okay. Void would be accepted, and here there is a special case for null pointer that you can actually, if you want to pass null pointer. I don't remember if the person, the original person was asking about this specific use case about null pointer, but just the person that actually answered kind of went above and beyond and just provide another thing. So if you take, there is a Godbolt link here. I'm not gonna click on it right now. Just this. If you enable this one, this API address of I, it would be would have the same error that I showed, like used of deleted function. So this is a very, very handy. Just remember that equal delete is not only for the special functions that the compiler is generating. Not only for that, it's also for other usage. Okay, so again, not a very known usage of equal delete, but I thought it's worth spending. Okay, spending time. Let's quickly go and talk about a book recommendation.
Can I ask a question?
Yes.
Why do you know why you need the delete? In this case, you could just declare an empty template too.
So say again, why it needs a delete?
Yeah.
In this case, it would be
if you don't define, if you remove the equals delete and you don't
Yes.
put a body for the templates, then the compiler won't be able to compile also. I mean, it will compile and complain that
not
the
link.
function is missing.
Not link.
Yeah.
Yes, yes. you are definitely correct. It's just a matter of where do you want to have the error in compile time or link time. But you're definitely correct that not having an equal delete. This is, by the way, the solution for before C++ 11. You'll end up with a linker error. Here you end up with a compiler error. But you are correct that it's giving you the same. In the high level, it's the same. It's the same.
Also the sequence, does it matter? First, you need to define the functions that you would accept, and then
the
define the
sequence
ones
here
that
is not
disables.
the
Not
sequence
really,
here
right?
not matter.
Okay.
The
The
sequence
compiler
here,
will prefer a function before a template.
yes,
So
it
that's
would.
why it will work for void.
Yeah, there is no specialization here. Everything here is overloaded. There is no specialization. This is a different story. We had a one item on it. It's a very interesting story, by the way. This is why all the trainer says don't specialize functions, but that's basically it. But yeah, everything you all said is true. Okay, the next thing would be the book recommendation. And this is something that I actually kind of an oversight. I went back to my past 2.5 years, and I have actually one slide that has all the book recommendation that we since day one. And I didn't see Clean C++, which is C++ 17 by Stefan Roth, and uh, I think he's from Switzerland or Germany. I can't remember. I'm sorry. But a very well respected and very well known. There are few people, by the way, from some of them are from Germany, some of them are Switzerland. I can remember that I'm following. They are trainers. I really like their work. Stefan is one of them, but there is I don't know if I pronounce his name correctly. I think Rainer, the guy from moderncpp.com. He's a trainer. He's talking. He's a speaker in CPPCon and other conferences. And what's his name? Jutis. I don't know if I pronounce his name correctly. I think he's also from Germany. So all of these um, uh, trainers, they have books and they're really good to kind of follow what they do. They have a very interesting work about C++. So Stefan is one of them. This is a really, really good book. I read this book a few years ago from cover to cover. It's I think has very good guidelines about writing clean C++, not going into the dark corner of the syntax or the dark corners of the language. It has everything covered in C++ 17, from using context pair to use polymorphism correctly, using inheritance, using const correctness, templates, TDD, function programming with Lambda, unit testing. Even has one chapter about unit testing, like G-test, and I think it has also catch. Proper object oriented. All of that is, I kind of highly recommend it, even if it's just 17 and not 20. Why? Because few months ago, maybe a month ago or a couple months ago, this is a 2021, Clean C++ 20 came up. And again, it has these solid principles, range. Now it has ranges, it has modules, it has all kinds of updated content. I personally would have both of them because they have different content. I have both uh, both books, but I actually own the physical, like the actually printed books, not only the PDF. I personally would recommend having both of them. They have different a bit of different content on each. 20 is updated with ranges, which is really cool to kind of read, and modules and all. Like I think one of the right now one of the best books would be these two. I highly recommend you take a look at that. Okay. Now let me see, how am I doing with time? I have 25 minutes. I think I can do it, but I'm not gonna have time for the wallet, folks, which is fine. But I have 25 minutes, so let me see if I can kind of cover the last section of my session. So, a matter of order. I was reading an article some time back. This is, by the way, a typo. This is GCC 11. Should be. I'm going to fix it on the fly for you. So, GCC 11, there was a very nice article about porting your C++ 17, porting your code to C++ 17 using GCC 11. What do you need to be aware of? Well, would your code either break, maybe silently? Like when I say break, it would behave differently. Or maybe your code would not compile because things would not work. Like compile error, which is good. You want compile error. You don't want like, oh, it used to be this value, now it's the other value. And we'll see some examples. And I'll say it up front before I forget. Don't, when you write code, make it simple. Don't make it smart. Don't kind of put lots of expressions or lots of stuff into one expression, I would say. Break it so it's more it's easy to reason about, and it's not going to break if you're looking at something that is unspecified. Okay, and I'll show examples that I personally think it's kind of scary. Okay, so here's the list. We'll take a look at the article in a moment, but some keyword removed. For example, register removed. The keyword doesn't mean that you cannot. It's not in register. It's not register not used, but the register keyword itself was removed. You still can do it with an ASM, like an ASM syntax. Then you can have register. But just what we used to have before C++ 17, or it kind of deprecated sometime in modern C++. You cannot do bool ++ increments. You cannot. Trigraphs removed. I'll show an example in the article. No except instead of throw or throw with empty parentheses. No such thing. Now, all kinds of small things that we already covered, like static const expression and const eval, are now they are now, sorry about it. They are now implicitly inline. This is what
So when
happens
you say no exception, are you saying it is no throw?
No. We used to have exception specifications. You say, I'm going to throw this exception or this list of exceptions. There is no such thing anymore. Okay. It's either no except true or no except false. Nice. I'm not going to go into this. We can have a session. Otherwise, I'm not going to finish. Sure, but sure. This is changed. By the way, we can do it in Qualcomm. I know you're from Qualcomm, so we can do that. Guaranteed copy elision that we already mentioned. So we have a copy elision that is guaranteed. Although we already saw that compiler were already smart. So let's go to the article just quickly. Share it. It's a very nice, it's a very short one, and I recommend you to take a look at. Okay, so removed. Okay, we said this one is removed. Bool, you cannot have ++. So where is my trigraphs? Where is it? Okay, this one. So they are removed. This is removed, but you can still have this ace. Oh, here you can still have this. That's fine. You can increment on is removed. You can the minus were never supported, but ++ not used anymore. What else? Exception specifier. So no except, but you cannot do throw. Where is the throw? Is there an example here somewhere? I don't see any example of throw, but I used to have throw with a list of what you're gonna throw. No such thing anymore. Oh, here it is. Here it is. This is removed. Error in C++ 17. There is a warning. It's deprecated in C++ 14, but not removed. It is removed. This is okay. No except means I'm not gonna throw. If I'm gonna throw, stud terminate would be invoked, and abort would be invoked, and I think unhandled exception might be. Let's ignore this template. This is a long explanation, and this is something that I mentioned, static on expert. Let's not deal with it. This is the important part. Changes of evaluation order. Okay, so C++ 17 with this P014 clarified the order of evaluation of various expressions. Proposal state the following expressions are now evaluated in such way that A is evaluated before B. So let's say you have A dot B, and there are both of them expressions that can be evaluated like separately. There, it was unspecified what would be evaluated before what. Okay. Same deal for all of this stuff. Even this one is not, which is the it's a shift or stream operator. It's not was not specified. Now it's specified, like A first, then B, and if we had C, D, and E, it would be with this order. Okay. And you can read that there's all kinds of strong or eval order. You can adjust it. But what I want to show you is this part. And if you don't have a cold sweat after reading this, you're probably not doing enough C++. Okay. Okay, this is what I mentioned. Let me just go here. Switch. Okay, so let's quickly take a look at this. So don't write smart code. Okay, let's take a look at the first one. So I have an integer, or I have an array, 4 integers. Okay, and I'm initializing it, everything to 0. Okay, now I have an integer I equals 0, and I have this expression. What I'm doing is I'm taking I, assign it to some location in the array, and then I'm asking what is the value of the first item. Return 0 in C++ 17, 1 in 14. Like this code, I can definitely see this happening in a lot of code base. And this is a disaster in my opinion, because there are different stuff happening now. So what actually happened here? Let's look C++ 14. Okay. So in C++ 14, we have this AR in 0, because I++ happens later after the expression. So I++ happens. So we have in AR 0 equal I. Now, if the I++ was happening after the whole thing, we would have AR of 0 equal 0. And that's what we have in C++ 17. The full expression is evaluated. Okay. And in C++ 14, we have this AR 0. And then there is a plus plus. And then it's being assigned to 0 location. Okay. Which is, again, in my opinion, is disaster. Same deal in, like, very similar. So remember, it was unspecified which one in the shift operator or stream operator, depends. It's both stream and shift, by the way. I'll show that. So let's take a look. C++ 14. Okay, so x is 2, and then we have x bit shift, and then x equal. So we have this expression. So what happens here is that there is an assignment, comma 2. So the whole expression would be eventually 2. So x would be shifted to But what is the value of x? If this is happening first, x is 1, and I'm shifting it. So x is 1, so now 1 is here, and I'm shifting it in 2 bits. So it's 4, right? So 1, 2, 4, because this whole expression assigning first, and then 2, and then now x is 1. But in C++17, x is first evaluated, so x is now 2. Now we are going to evaluate here. X is 1, fine, because we don't care right now because this part is already evaluated. And then 2 is the end of the whole, because of the comma, it's the end of the entire expression. So you have 2 shifted by 2. So 2, 4, 8. Okay. Same deal here. It's exactly the same. If x is if this is evaluated first, so we have 5. So x is 5. So try to imagine 101, 5 shifted by 1. It's 2. It's 1, 0. But if it's 6, it's 1, 1, 0. Shifted by 1, it's 3. It's 1, 1 in binary. Okay. Again, if you don't have sweat, cold, you're not doing C++ enough. So the different stuff happening.
So that depends on how doesn't the compiler look at the dependency of the data dependencies?
No. It's evaluation order. The compiler decides now in C++17, the compiler needs to evaluate per specific order that was accepted in this proposal, this P that I mentioned. And there is a link there's a link to the proposal in the GCC's 11 link.
No, for example, in the first case, right, function, let's say AR I++ 1 equals I, and then return AR of 0. So why would that be different in both the cases, 17 and 14?
It really depends when to increment the I. Do you increment the I after the whole expression is done? Or you increment the I when you're done with this, you do equal, and then I now is 1.
It wouldn't be the whole expression. It would be the bracket versus the right side. So do you increment first to figure out what is the index that you want to use for AR, and then figure out what is the value that you need to put in the array? Or do you figure out what the value is and then compute the index?
But that's what I'm asking, right? So wouldn't the compiler be actually using a dependency between those variable references or variables or a copy of the values?
There is no dependency here. There is no dependency.
No, we have, right? Because we are using I, for example.
Yeah, but there is no such thing. There is no dependency.
But even if there is a dependency, it doesn't tell you which one should be first.
Exactly. There is no
yeah, that's what I'm trying to understand, right? So if there is a dependency, then obviously that will determine the way the compiler has to sequence instructions when it generates from high-level language to assembly or the machine code if it does directly. But if that is not the case, then either the spec is incomplete. That's why the behavior is coming up, right?
Yeah, I'll need to kind of advance to the next thing because I have 10 minutes and I want to complete that. So there is a very famous Stack Overflow question that there is a link here, but I just capture some of them. It's a very, very famous one. C++17 evaluation order guarantees. So there is a proposal 0145, and here's a typical code. So the person asks what happens here, and what happens here, and what happens here. Okay, there's 3 different. Is there any specification about what's happening here? Is there any specification of what happens here? And same deal for this one. Okay, let's just go one by one. And I'm sorry, I don't have time kind of to explain more than that. This is unspecified in C++17. It was undefined per the Stack Overflow. I didn't read recently the proposal. This is a very old Stack Overflow question, by the way, very famous one. This is unspecified, not undefined. Used to be undefined, but not specified. Okay, this one is the interesting part. Was unspecified, but remember what I told you before? This table from the C++, from the GCC 11 page. Now it's become compatible with operator precedence. So the first, this one, C out, F, F, and F. Now, this part has unspecified order. You don't know if G would be called first, or J would be called first, or maybe H would be called first. But if you remember from the table that I showed, or the list, if you have getF that returns something that is callable, and then you call it, the rules instead that getF would be evaluated before G, H, and J. Oh, sorry. Okay, this is one. Let's say A is a callable object, and then B1, B2, and B3. We don't know what the order of B1, B2, B3, but first would be A. Okay. Now, one of the things that you need to remember is that one of the things that guaranteed by 17 is that G fully, if G is first, it is guaranteed that the full expression would happen, and then the full expression of the next one. It's not going to be like interleaving stuff. The compiler is not allowed to have sum of G and then sum of J and sum of H. No, if it starts with G or with H or with J, completes the entire expression, then it goes to the next one, entire expression, and then the next one, entire expression. So it has a very nice example that this one used to be, okay, this one I actually want to show because it's really nice. We're quickly going to take a look at it. Where is it? Where is my code vault? Here it is. Okay, so this is the 14. You see, I'm not going into the actual explanation of what's happening here, but speaker is a function that has a callable object, operator parentheses, and so it looks like a function, and it has a state. Okay, but the question is, depends on which one you call first. You see, play, no, and walk all, and then there is this new line. So there is no order. While we actually were expecting to have this order, all walk and no play, and then and just go. I don't have time, but just go later and just look at it. But in C++ 17, it's guaranteed. So we have all walk and no play, and then \n. So the actual code is not important. The important part is that this looks very innocent code used to be an issue before 17. I'm looking at 14 here with O3 with GCC 5.4. What happened? The reason I'm choosing 5.4 is because at some point, even before 17, compilers started looking at this proposal and start implementing it. So they would be, but I was working in companies that 5.4 was the compiler with 11 or 14. So they would have this behavior, which is, if you think about it again, it's kind of scary. This is a toy. It's a toy program, but think about something that is kind of more serious. Okay. See. So for some reason, it doesn't let me to present. Oh, now it does. Okay, so so this is what I told you before. I'm not going to explain that in details, but we used to have this issue that if you have this 2 parameter and you have this 2, before 17, this was unsafe. You could have new A, You're not assigning it to the unique pointer yet, and then you jump to this one. This one would fall. This one would. This one would fall.
You're not sharing your presentation window.
Okay, let me see why. So what did you see?
I was seeing the slides, the list of slides.
Okay, sorry. Thank you for not letting me know. Okay, so before 17, this was unsafe. Why? The whole point of unique pointer or smart pointers, distractions, they'll clean up, even if there is an issue in exception and all. Think about this specific scenario. I have a unique pointer here and here. I'm passing them to foo that accept unique pointer A. And I am creating new A and new B here. So let's think about the scenario where I start with this guy, creating the unique pointer, allocating A. I'm not assigning the allocated A yet to the unique pointer, and the compiler generates code that start initializing B, and it does new B. Now new B is now let's say it's assigning it to the unique pointer. Now something is happening and it's throwing. Since the unique pointer doesn't own the memory block yet, it would leak. This new would leak. But C++17 guaranteed that if we start with this specific expression, the entire expression gonna finish before we go to the next expression. So if we are done with A and we go with B and it's throwing at any point, A would be distracted correctly. There is no leak. Okay, so that's something that is really unique. Now, there is something that I showed in Qualcomm, and I just want to focus on one thing that I thought was really interesting when I kind of dealt with it. And long story short, let's say, let's see how I am with time. A few minutes, I think it's enough time. Let's say I have this array where I have all these ones, and I want to print. Let's say I want to have the maximum ones, but the idea is, let's say that in addition, I want to print how many ones I have with each of them. Like this is kind of a side effect I want to do. So for example, in index 0, I have 3. In index 2, I have 2, and so on and so forth. Okay, so this was kind of like a lead code question that I have a very non-performant solution, but it showed this order of evaluation very nice, and I wanted to kind of share this with you. Okay, so let's say we can ignore that, but basically kind of all kinds of games about using extend. Since I don't have time, I'm gonna skip on it, but you can take a look. It's basically, it gives you information about how to use extend and size of to get the size of each dimension of the array. But that's not really important. It's kind of an exercise. I would like to take a look at transform reduce. It has a multiple overloads, and the idea behind transform reduce, sometimes it has 2, sometimes more. Actually, it has only 2 or a single range, either 2 ranges, and I'll show an example. And it has 2 operations. One is transforming something, and one is reducing something. For example, let's say I want to take 2, I make operation on 2 series of ranges, and I want to sum it, or I want to make an inner product. Okay, so here's an example. I have 2 ranges. I want to have the inner product, so I multiply each of these pairs and sum everything, and I have a solution here. Transform reduce, which is basically what we call from functional programming, it's a mapping and a fold. The reduce is a fold. It's basically a transform is I'm taking something, either a pair or maybe even one thing, and I'm making some operation and getting something else out of it. Reduce is I have a series of things. For example, summing everything. A sigma is a reduce or fold. The mathematic sigma. So accumulate, std accumulate is a type of a reduce or a fold. So that's what I'm gonna do. So let's prepare the ground. So what I'm going to do, I have a series of ranges. So I'll take this one. I'm going to sum it up. Then I'll take the other one. I'm going to sum it up. This one, sum it up, and then I'll have the maximum of all, and this would be my answer. But in addition, I'm going to print with index 0, I have 3. In index 1, I have 2. I'm going to have a cout, okay? So here's one thing. I'm taking some value. If you don't know about lambda, just ignore all of that. We take a look at the body. I have an array that would be V. It's a range, okay? So I have 0, 1, 1, 1. This whole thing would be V, and I'm doing count if the value is not 0. Or actually, I'm just counting it. So 0 would be 0. So 0 plus 1 plus 1 plus 1 would be 3. 0 plus 0 plus 1 plus 1 would be 2. And then I create a tuple. So this is a stateful lambda. Don't make a stateful lambda, but this is just for demonstration. And I'm returning a tuple of the index. So index starts with 0, so it's a stateful. So every time I call it, the index would be incremented. So I have 0 and the count. So what I'm going to end up with a series of tuples. The first tuple would have 0, 3 because it's index 0. There are 3. The second tuple would have index 1. There are 2. The third one would have index 2, 4, and so on and so forth. Okay. And what I want to do is just have the maximum and say index whatever, which is index 2. It's a 0 based. Index 2 has the maximum amount. All ones with 4 ones. So this is the predicate, the binary one, which I get the maximum so far. And I'm looking at the second of the tuple. Remember, the tuple has an index and a sum. So I'm looking at the second one, which is the sum, and I'm just returning the tuple that has the maximum. And the final transform reduce looks like this. Again, it's not the best thing that you would come up with, but it's a perfect example of how things can surprise you. Now, if I put it on the compiler and I run it, and I have the link to the compiler explorer, I was actually very surprised to see this results. So it says the following: 2, which is basically the first, like the index 1. 3 was index 0, but it came up with 1. Then I have 2, okay, which is also this one. Then 4 and 0, like things got reversed. It's like some of them are kind of reversed, right? It should be 3, 2, 4 to 0. Okay, so this is the index 1, 0 to 4, but it's not matching. And again, if you go back to the lambda that's actually doing this work, it's counting whatever I'm giving it, and then assigning an index, and the index is 0, 1, 2, 3, and 4. So that was kind of very surprising. Like, why I have that? Because it should be in order. Like the first one, like the transform reduce would take the first array and do something with it. Then they take the second array and do something. So why I have this mixture? So looking at the standard library, without even going into a lot of details, but you can take a look at that. This is a copy paste from the standard library implementation. You see this unary operation with first 0 and first 1. Basically, there is a function that is passing. There's a function that I'm passing functions to this function as an argument. Okay, these two functions are these unary ops are functions, but I kind of relying on the order of of operation. And what happened? It takes this in pairs. So what does it mean? It means that when I pass these two arrays, the first array and the second array, not me passing, but transform reduce is working on it, and it has this binary operation. It's actually taking this part 0, 1, 1, 1 and invoking it second, and it's taking 0, 0, 1, 1 and invoking it first. So it's assigning the first index to the code, basically to the instance the code is actually running, that actually takes this array. So this is the kind of the idea behind this, that you don't know what is being invoked between these two. These two are my lambda that are being passed to the transform reduce, and it's being taken in pairs, not one after the other, but basically in pairs. So this is basically the sad story, and we're not going to have time for the wallet folks, but we'll do it next time. And let me show you the compiler explorer. So this is the whole thing, and here's the results. You can see that index 0 was assigned, this row was assigned to index 0, and this row would assign. And if I actually print here, you can see that it's going to be like more debugging. You can see that this is actually what happens. And I actually looked at the standard library implementation, and that's what actually triggered my entire idea of providing this. I think it's an interesting twist in C++ 17. What I mentioned before, this is used to be undefined and now unspecified. So it's unspecified which would happen first. Yeah, the moral: don't use stateful lambda if you don't need to. That's like what I'm showing here is anti-pattern. Don't use it. But it's really nice to kind of demonstrate this very awkward situation. Have a simple code that would not break if things that are unspecified start to be specified, and A.B become specified when you're relying that B would always be evaluated before A. So don't do this. Have a simple expression that is not gonna break. So that would be it. It's 6:40 right now.
So can we compile the code with C++11 and see how that works? Or still
we
have the same problem?
It's gonna be the same problem.
I see. Okay.
I don't think this is gonna make any. This is 2A, but I can show you 11.
But I think this is a problem even with C also, right? Any function which is
it doesn't have std size. Let me just take this whole thing. Let's do 14 because I have auto here in the lambda. So let's do 14. We don't have tuple. Maybe I should have just include it. Okay, so transform reduce might be in. Let me see. Transform reduce. Okay, transform reduce. Bummer. It's from 17. So yeah, we could do, you know what? Maybe we should be able to. Let me think about it. Can we do inner product? Would inner product work for us? No, it's not. I'm actually missing one overload. So it has the 2 operator, which is fine. I have the init, but it doesn't have an overload that has only one range. This is what I need here. In transform reduce, I have one range, I have an init, and then two of the operations, which I don't have, unfortunately. So no, and the first one is actually binary. So it's not going. I'm not unable to show you in 17, unfortunately. I'm sorry about it.
That's fine. And also, I see you're using std clog. Is it something different from cout?
Oh, it's just unbuffered.
I see. Okay.
It's there is a very clog versus cout. It's a very nice here. This one, very nice and famous. I should probably do this. It's a very nice one which tells you which one are being so C error is to standard error unbuffered, immediately flashed. C-log is stood. Okay, let me see if that's C. I'm going to show you something that is more. So C error is stood error, C out is standard out, and C log stood error. I think it's unbuffered. It's also C error is sorry. C log is buffered. C error is unbuffered, and both of them are stood error. C out is standard out, and it's is it
buffered?
Is unbuffered? I think.
I think it is still buffered. So I see. Sometimes you have to use flush after that. Yeah.
Yeah. There is a good. I'll find something. Oh, here. So zero is unbuffered. C-log is buffered. Which is zero. Cout is instant. It's used to produce output to standard output.
I see. Okay, got it.
I think this is.
That's also buffered.
Buffered, I think. Yeah, this is why you see the. So it is buffered as well. C-error is unbuffered, so make sure that you know what you're doing if you really want to kind of, it's flashing it. Yeah.
Okay, thank you.
Okay. I think we should be concluding for today. Thank you for everyone joining me. We'll see you next time.
Take care. Good night.
Thanks. Bye-bye.
Thanks,
Kobe.
Kobe. Thanks, guys.
Thanks.
Thank you, Kobe.
Thank you.